This homework I call more pour. So we did the glass pouring example where we had two glasses and we could pour between them. And we're going to do the same thing here, except we're going to allow an arbitrary number of glasses. And so, for example, here I've drawn four of them. Let's say their capacities are 1, 2, 4, and 8. And let's say we set ourselves the goal of having 5 in one of the glasses. How could we achieve that? Well, here's one solution, is we could fill up this glass with 8. That would be the first action. Then we could empty out or pour 1 into here. Now we'd be down 1 and be at that level. Then the second action would be to pour into here. Now we'd be down 2 more. And we find we're at 5 here. So that would solve the problem. An alternative solution would be to fill these two glasses with 4 and 1 and then pour both of them into 8 to achieve 5. So your task will be to define more pour problem, which takes a tuple of capacities of glasses, any number of glasses, and then a goal, which is a single integer that you're trying to achieve. Alternately, you can have a start state of what's the current level of the glasses are. If the start state is none, that means 0 for all of the glasses. Your task is to return a path which achieves the goal, or return the empty path or failure if there is none. And the paths, like before, are an alternation between states and actions, where the states is just a tuple of current levels, not of capacities, but of current levels. And then the actions can be either fill, empty, or pour, and we're going to describe the glasses by their index numbers. So in this list of capacities, the first number in the list, we'll call that glass number 0, the next one glass number 1, and so on. So when we filled up the tallest glass, that was the last glass out of 4, glass number 3, so the action would have been fill 3. And here we have a test that says the problem I just solved for you by drawing it out. The actions are fill glass number 3, pour glass number 3 into glass number 0, then pour glass number 3 into glass number 1, and then you're left with 5 in glass number 3. And here's some more test cases to check things out for you. See if you can solve those by writing your program. Use what we have seen before. You'll probably want to use one of the search procedures we've already defined, and you'll probably need to write a custom successor function which understands the current state and the capacities. And let me just say, I've seen some discussion in the forums about, can I find a one-line solution or a two-line solution? Don't worry about that. The solution will be whatever it is. The sort of setup to solve the problem should be a call to a function we've already defined, so that will be one line. But the successor function, that might be a dozen lines, maybe a little bit more or a little bit less. Don't worry about minimizing it. Worry about making it clear.